This video is about configuring OSPF in Commando Marshall C3500 series routing switches. So OSPF is a link state protocol that runs on Digistra's algorithm, which uses path cost as a basic for routing matrix for path selection, and it send and receive packet on the port number 89. So let's start configuring OSPF on Commando routing switch. So you can see by default there is a minimal configuration in the switch. We'll change this VLAN 1 IP address and we will connect OSPF source to port number 9, which is connected to the router which is running OSPF already, and that router will be the top brand routers which are generally used by the network engineer. So by default there is no route in the routing table to reach any network. So first of all we will go for configuring the interface. So interface VLAN 1, and I will give the IP address 192.168.0.1/24, and after giving the IP address to VLAN 1 we also will give the IP address to interface ETH-0-1. We will say no switch port and give the IP address 192.168.1.2/24. we say no shutdown. Exit. We will run a OSPF process router OSPF 1, and we will give the network 192.168.0.0/24, let us say area 0, and other network 1.0 area 0. So we will see whether the routes are calculated by the OSPF routing process to the other router. Currently it is under process. It will calculate the route and we will get the OSPF learn route by this router in short while, where OSPF uses some timers to decide how often to send the OSPF messages on the interfaces. That timer is called as hello interval and default is 10 seconds. So it is taking time to learn the OSPF learn route. And we can also have the dead interval timer, the timer that decide how long to wait without receiving a hello from the neighbor before believing that neighbor has failed. The default is the 4 times the hello timer and the default is 40 seconds. So you can also configure the timer in OSPF. We will see the current configuration. So we have run the process 1 with these two networks and we have given ETH-0-9. Oh, we have not given the IP address to config T int ETH-0-9, which is connected to that port, no switch port, and then IP address 192.168.1.2/24. so already some okay. int ETH-0-1 switch port, exit int ETH-0-9, and then we will give the IP address to this port because we have connected the source to this port. Now we will check show IP route. So it will come active because it is having some timers. The OSPF route is learn right now. So this is the OSPF learn route where I have connected ETH-0-9 to the OSPF enabled router on the other end, that is a top brand router. So we will also learn how to configure, how to see show IP protocol will show the routing protocol used, and also we can see the show IP OSPF database. To see the router link states for area 0, net link states for area 0, and external link states for area. We can also see the interfaces involved, show IP OSPF interface. So this is the interface which is involved, which is ETH-0-9. We can also see the show IP OSPF neighbor, so it will give us the neighbor information. So you can see the state is full DR, and we have already seen the show IP route to see the OSPF route. We can also give the area authentication command to enable authentication for OSPF area, specifying authentication for an area. Set the authentication to be simple password, or it can be MD5 depending on our choice. If I give the OSPF authentication at this end, other end also has to give, otherwise OSPF will not run properly. So I will show you how to do it, but we will not implement that command, or otherwise I have to do on other end also. INT ETH-0-9, and we have to give IP OSPF authentication key, and we have to give the key, and this will be set. We can also change the default cost command to specify the cost for default summary route sent into a stub area. The default cost is 1. The command used only on an area border router attached to the stub. There is 2 stub area router configuration command, the stub and the default cost option of a area command. In all routers and the access server attached to the stub area, the area should be configured as the stub area using stub option of the area command, or use the default cost option only in an ABR attached to stub area. So you can also have this option in the OSPF process. Router OSPF 1, and we can have this area command, and any of the area, let us say 192.168.0.0, and we can define it as a NSSA or stub area depending on our choice. We can also have the area filter list command to filter the prefix advertised in the type 3 link state advertisement LSA between OSPF areas of an area border router. So we can also use the area 1. So let us say area 0, and we can have this filter list, and prefix we can define, access list or prefix list we can, and we can give the area or in or out. We can also use the default cost command. So we can define the default cost for an area. So for that, let us say area 0 default cost, and we can define the cost, let us say 20. As it is a backbone area 0, we cannot configure that. For other areas it is easily can be configurable. We can make it NSSA, we can make stub, we can have the range which will summarize the routing matching. So these options can be easily configured with commando switches. So this much commands are there which can be used and help you to configure the device in the proper manner. We can also define the default information originate to generate default external route into OSPF routing domain. Whenever we use the redistribute or the default information originate router command to redistribute the route into an OSPF routing domain, the commando switch automatically becomes an autonomous system boundary router. However, an ASBR does not by default generate a default route into OSPF routing domain. So we can have this command called default information originate, and we can set the matrices. Let's say I want to have matrix 100, matrix type 1. So this way we can configure it. So we can also redistribute and define the distance in this. So distance, let us say 20, and redistribute. Let us say we can redistribute any of the routing protocol which we want to redistribute in this process. We can also redistribute, let us say I want to redistribute connected routes also. We can also have the cost defined for particular interface. For that we have to go to the interface ETH-0-9, and we can define IP OSPF cost. Let us say I want to make the cost 60. So this way this cost is set, so OSPF process don't have to calculate the link cost, automatically it can be set. We can also set the timers like IP OSPF dead interval, or we can also set the IP OSPF hello interval. We will go to theory after this. So this can be changed. Generally hello interval is 10 seconds and dead interval is 40 seconds, which can be changed. We can also have the IP message digest we can create, but I will not set because other router also we have to do. We can set the IP OSPF MTU size, and we can set this MTU value also. After this we can set the priority also. So this priority command to set the router priority, which has to determine the designated router for this network. So we can set the IP OSPF priority. Let us say I want to make it 4. We can also have the different types of network configured. We'll go to theory later on. So IP OSPF networks. So these types of networks can be broadcast, non-broadcast, point to multi-point, and point to point. Let us say I want to make it as a point to point network. So by just giving the command, it is very easy to configure the things. We also can have the summary address, which is a very important command to create the aggregated address for the OSPF. Use the summary address command in the router configuration mode. So exit router OSPF 1, and then we will give the summary address command, and I can summarize my addresses to one of the addresses which I want to have summary for that. So we can see the various shows. So basically show IP protocol OSPF, then we can also debug, show debugging OSPF, so it can be debugged also. So terminology used in OSPF is firstly is the LSDB. It's a link can be considered as a layer 3 in the link state, it's the description of that interface and relationship with the neighboring router. The collection of all these link states from the link state database. So the some links can be up, some can be down, and that database will be maintained in the link state database by the DRs. Then router ID requires every router requires a router ID to run the OSPF. The router ID is a 32-bit unsigned integer uniquely identifying a router as a AS. A router ID can be manually configured or automatically selected by the router. The router select its router ID based on the following rules, like if the router preferentially select the largest IP address among the loopback interface address as a router ID. If no loopback interface is configured, the router select the largest IP address among other interfaces as its router ID. Then cost. So cost is used as a matrix for path selection process. By default, the formula to calculate the cost is 100 Mbps divided by the interface bandwidth. 100 Mbps is the OSPF reference bandwidth, and the cost of OSPF route is a sum of the cost values of the all incoming interfaces from the source router to the destination router. Then route types, we are having different route types. Show IP route will give the route types. So we are having the type 1 external route, type 2 external route, intra area route, inter area route. We are also having OSPF packet types like hello packet, which send periodically to discover and maintain the OSPF neighbor relationship. We are having database description packets. It is a brief information about the local link state database LSDB and the synchronized LSDB between the two routers. Then link state request packets to request the neighbors to send it is requesting a neighbor LSA requesting neighbor to send a LSA. LSR packets are sent only after DD packets are exchanged successfully. Then link state update packets, LSU packets, are sent the required LSA to the neighbors when the router detects the topological changes or there is some link failure or link up and down. It sends a link state request packet to the neighbor requesting the database. It carries one or more link state advertisement one hop farther from the origin. So the router acknowledge all link state update packets, and if retransmission is necessary, sends the retransmitted advertisement unicast. Then acknowledgement, so it's a TCP based, so for every link state send advertisement sent, it will acknowledge the packet in response to link state update packets. We can also have the various LSAs. So by default there are from type 1, 2, 3, 4, 5, 7, 9 and 11. So router LSA we can have to describe the status of the link cost of a router generated advertised in the area that the router belongs. Type 2, which is a network LSA, describes the link status of all router in the local area network segment generated by DR and advertised in the area to which the DR belongs. Type 3, which is a LSA named network summary LSA, describes the routes in the network segment and advertise the routes to the related non-totally stub or NSSA area. Type 4 is a ASBR summary LSA, describes the route to an ASBR generated by an ABR and advertised in the related area except the area to which the ASBR belongs. Type 5 is the AS external LSA, describes the routes to the destination outside the AS generated by an ASBR and advertised in all areas except the stub areas and not so stubby area NSSA. Type 7 is a NSSA LSA, describes the route to the destination outside the AS generated by an ASBR and advertised in NSSA only. Type 9, 10 and 11 are opaque LSA. It is a OSPF extension graceful LSA used to support GR and is the type 9 LSA. Example, type 10 LSA is used to support T. So we can have the router types also apart from the different types of LSA. So we are having internal router where all the interfaces on the internal router belong to same OSPF area. Area border router and ABR belongs to two or more areas, one of which must be a backbone area, and area 0 is a backbone area. So an ABR is used to connect the backbone area and the non-backbone area. It can be physically or logically connected to the backbone area. Backbone router, at least one interface on a backbone router belongs to backbone area. Internal routers in an area 0 and all ABRs are backbone routers. ASBR, area autonomous system boundary router, exchange the routing information with another AS. Then we are having the area types also. Area 0 in OSPF, all the router in area 0 are called as backbone area. Regular area is just non-backbone, non-zero area without a specific feature generated and receives summary and external LSA. The backbone area is a special type of area. Stub area. The stub area does not advertise the AS external routes but only intra-area and inter-area routes. Totally stubby area. A totally stubby area does not advertise the AS external routes or inter-area routes but only intra-area routers. NSSA, not so stubby area, and ASBR uses type 7 LSA to advertise the imported AS external route to entire NSSA. These type 7 LSAs are translated to type 5 LSAs on an ABR and are then flooded into the entire OSPF AS. Totally NSSA is an ASBR use type 7 LSAs to advertise the imported AS external route to the entire NSSA. These type 7 LSAs are translated into type 5 LSAs on an ABR and are then flooded in the entire OSPF AS. There are network types which we have already configured. So OSPF network types are point to point, point to multi-point, non-broadcast, multi-access and broadcast. And the OSPF uses the term DR and BDRs for the use. DR is a router interface elected among all routers in a particular multi-access network segment, generally assumed to broadcast multi-access. The router sending the hello packets with the highest priority wins the election. If two or more routers tie then highest priority settings, the router sending the hello with the highest router ID wins. So this is very important to maintain the complete topology table of the network. So DR will always maintain a topology table, and BDR, if DR fails then it works. OSPF routers goes through the process like down, attempt, init, two-way, start, exchange, loading and full to learn the routes. And for three main process to enable the OSPF router exchanging LSAs and calculating routes like neighbor relations with the help of hello packets, exchanging database and finding the best routes. Thank you for watching this video, and hopefully you understand the OSPF configuration and concept with this video. Thank you.